everybody. Now, I can't tell you how many times people ask me about Tesla turbines and wind turbines, loads of times actually. I'm pretty sure most people know what a Tesla turbine is, but for those who don't know, it's basically a stack of discs placed quite closely to each other. When a fluid flows over those discs, and by fluid I mean air or water, it goes in a spiral and creates a friction at the boundary, and this drives the turbine. It's bladeless, and it's really quite an interesting device. And the idea has always been, can this be made into a wind turbine? Well, an effort has been done for that with the solar wind turbine, which is basically a Tesla pack in an involute, and they point the involute at the wind comes in the involute, spirals round and gets jetted over the turbine, and that drives it, and that's supposed to work really quite well actually. But I was mulling this over and I was thinking, well, that idea of a gas, a fluid, air entering two flat discs and spiralling, well, do they actually need to be discs? What about if there were cones? And so I came up with this. I did this quick drawing of a stack of cones to make effectively a Tesla turbine which would be unidirectional. So I printed them off, and here's the first part of it. You can see the cones all nest in each other with a small air gap, and the idea here is that the wind will blow directly on here. Because it's blowing directly on here, we should get the same effect. That is, it should spiral, it should create a friction at the boundary, and it should turn those cones. And of course, with something like that, all we actually have to do is put a tail on it, and of course it will point itself automatically in the wind, and the wind should enter there and turn that. So let's finish printing that and see if that actually works. Okay, and there it is all put together, and I've put on a neat little stand, and I've also drawn a black mark on there. But on the test, when it began spinning, I couldn't see the black mark, so I put a black flag on it there. Now, in a normal Tesla turbine, if you point the air straight into the turbine, nothing will happen. You have to point it at an angle to the disc, which is why the solar turbine has got such a big chunky outside bit, because that airflow has to be pointed a similar direction. And looking at the cones, I would think exactly the same thing would happen. If the air was coming straight in, I suspect it won't do anything. It needs to be at an angle. And I'm going to use a hairdryer to demonstrate that. So we put the hairdryer straight on. Yeah, it wobbles around a little bit, but not very much. Now, if you put it at an angle, and it looks to me like the angle is the angle of the cone. It's very cool. I mean, it's a proof of concept prototype, eh? To see what kind of power we're getting out. Of course, we need to do something like a prony brake to measure the torque. Would be the ideal thing, because then we'll know what torque it's generating, and that'll give us an idea of what generator we can attach to it. But it turns quite well, as long as the wind enters at an angle. Now, this is my first mock-up from that idea. I didn't think that we necessarily needed to be slaves to the Tesla turbine, thinking it only of as flat discs. As long as you have those two separations, it looks like it's going to work fine. And if you think about this a little bit, of course, I don't know if you've ever seen a hyperbolic funnel. Well, it looks like this. And you'll have seen hyperbolic funnels in things like wishing wells. You drop a penny or a marble and it spirals round and round and gets faster and drops down the centre. That really makes me think, well, how about instead of stacking cones, we stacked hyperbolic funnels together? Would that improve it? The angle of attack would still be the same, I would think, but it creates its own vortex as it goes. And of course, if this is free to run, then that should give it a bit of extra push and extract some more energy out of it, maybe using hyperbolic funnels, I don't know. In order to get a real estimate of this, of course, what we really need to do is measure the torque on the shaft there with maybe a prony brake, and that'll give us an idea of what generator we could attach to it. But as a proof of concept, I think it's pretty clear that as long as we have two laminar flow layers with the small separation between them, the geometry isn't as important. It doesn't matter if it's a flat disc, it doesn't matter if it's a cone, and it would be really interesting to see what a hyperbolic funnel would do. Now there we go, rethinking the Tesla turbine in light of wind power, and of course it would work just the same with water. If we dropped water in there at an angle, we should get that to go crazy. But I thought I would share that early stage proof of concept with you. It's certainly something that I think is very interesting and something I'll be looking at a little bit more. I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.